All right, good morning. Hope you had a good weekend. I wanted to go over some notes for 7.4 and 7.5, as well as towards the end, some stuff for 5.3 and 5.4. Okay. If you would rather focus on 7.4 and 7.5, and then take the quiz, and then continue watching the video for 5.3 and 5.4, then by all means, go ahead and do that. All right, so a couple things here. We're going to look at what's called the geometric mean. So in a proportion here, B and C are the means, okay, and they equal um, uh, the product here, okay. So here, um, x times x is equal to A times B, all right. So just jumping straight into an example, um, find the geometric mean between the following numbers, like 4 and 18. Okay, so you would set up this proportion of 4 over x is equal to x over 18. Okay, and we already went over how to solve for a proportion. Right? We're going to cross multiply, and you're always going to get x squared equals a number, right? And so this is one of the reasons why we went over simplifying radicals. Okay, so you gotta be able to do that. All right. Here, theorem 7.3, um, the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. All that to say that there are three similar triangles, right? And so it can be a little confusing. Um, and hopefully you're going to read over these notes carefully. But one thing that might be helpful is to draw the triangles in the same orientation with corresponding parts, right? And so here the overall angle Z is the 90 degrees, and here's the large overall triangle, XZY, right? And so we drew it so that the 90 is here, single tick mark up here, and the double arcs over here. And so for the two other triangles, right, because you have triangle um, XAZ and triangle ZAY, but we kind of flip them around and turn them around so that they're in the same orientation. Okay. The altitude is a line from a corner, right, that goes across to the other segment, to the other side, and creates a 90-degree angle. Okay. Altitude always implies 90 degrees. All right. Okay, so here, and if you look at the announcements in Google Classroom, all right, this is what we are referring to, the altitude hypotenuse theorems, okay? You are going to get, um, you're going to be able to use that sheet, that file on the quiz, okay? And so here, again, here's the overall triangle ABC, right? And so, and I think it's here, this is the 90 degrees, okay? So what we did was we drew the triangles in the same orientation with corresponding parts, right? And so you gotta look carefully on how to do that, right? You gotta look at the triangles carefully and think about which corresponding parts match with the other parts, and I think it's helpful to draw these triangles separately. Okay. All right, similar idea here. Again, just redrawing it. Okay. This is just an example with numerical values. Okay. All right. So again, if you can't tell, I'm trying to emphasize this. Redraw the triangles so that you can see which sides correspond to each other to make these proportions. Okay. And if you notice, look at these setups, right? This is the first part of the lesson, the geometric means. Here's another one. I believe now we're in 7.4, day 2. Okay. Again, couple more of these, right? We try to color coordinate it so that it's easier to tell. And I think this is going into 7.5, right? You got to know these terms, what the visual looks like, okay? Definition, all right? And the point of concurrency, okay? Let me explain that here with median, okay? Now, with median here, all right, you'll notice, okay, a median is from a vertex, from a corner of a triangle, to the midpoint to the other side. It does not, okay, it does not cut that angle in half. That's what the angle bisector is, okay? So median talks about splitting the side of a triangle in half, okay? Now the thing is, there are two other medians, right? Like from here, from this corner to this midpoint here, I'm going to try to draw this, right? Okay, that's a terrible dot, okay? Or I'm going to cheat here, okay? Right, that's another median. Then I have yet another median from, let's make it right, from this corner to this midpoint, right? Now, obviously, I'm just kind of guesstimating, okay? But I can draw another segment there. There it is, right? And so what will happen is there's a point of intersection where the three medians will meet. That's called a point of concurrency, right? And so for this one, okay, the point of concurrency when three medians intersect is called the centroid, okay? The angle bisector, right? This one is the angle is cut in half. That doesn't mean that the side opposite is cut in half, okay? The angle is cut in half. And so you can do that with the other two corners of the triangle, right? You can bisect those angles, and that point of concurrency is called the incenter. Okay, so these have different vocabulary words. All right. So this is going to be pretty important to know, right, for the quiz and for the final that's coming up in a few days. And just a couple of proofs here. Okay. I believe this is on your proof sheet. If there's a median, then there are two congruent segments. And if there's an altitude, then it creates two right angles. Okay. So take a look at this. These are all, statements and reasonings that we've gone through. Okay. And so hopefully that'll be helpful. All right. Here's another one. Okay. AM is the perpendicular bisector of XY. So that means angle XMA and YMA are right angles because if perpendicular, then right angles. You have to declare that. And then you can say those angles are congruent because if right angles, then they are congruent. Okay. XM is congruent to YM, not because of midpoint, but because it's a bisector, right? We're not given, it doesn't say in the given that M is the midpoint, but rather we're told that AM is the perpendicular bisector. So if bisector, then two congruent segments. Okay. And then, of course, there's reflexive property, and by SAS, right, side angle side. These two triangles are congruent, and therefore, XA is congruent to AY because of CPCTC, right? Remember, you can only use CPCTC once you've proven a triangle to be congruent. All right. Okay, so if you have questions, please shoot me an email throughout the morning, okay? Especially 7.4 and 7.5 material, because these last few slides are from 5.3 and 5.4. But 7.4 and 7.5 material, if you have questions, please, send me an email. If you need to take screenshots of the notes on, on the questions, please do that, okay?